Uh, Yo, what's up, guys? I currently am outside right now in leetcode with my friend Rudy. He's about to eat right now, and I think we're going to call in about 30 minutes. But the problem we're going to today is called longest consecutive sequence. It's a question that involves arrays and hashing, and so given an unsorted array of integers, return the length of the longest consecutive element sequence. Return the length of the longest consecutive elements sequence. And you must write an algorithm that runs in big O of n time. Okay, so example 1, the inputs, you have a list of numbers, and then the output is 4. So the longest consecutive elements sequence is 1, 2, 3, 4. Therefore, its length is 4. Okay. I'm automatically thinking about if we were doing this problem, some strategies we could use, maybe having some type of hash map structure that can keep track of, let's say, the number of elements that come before or after it. That maybe could be one that'll run through big O of n. So let's try this example first, right? You have a list of numbers, and let's say you have a hash map. You take in this number itself, 100, you put that into our hash map, and then you put that and then the key is going to be 100, the value is going to be 1. So let's see that. Then you go into your next number, you check if 4 is in the hash map, and if it's not, then you insert it into the hash map. You check the number is higher, the number is lower. If it doesn't exist, then you just have the same idea where you do a key of 4 and then a value of 1. So let's see first example. So 100, I'll do a hash map, and then maybe a counter. Okay, so here's what we'll do. $100, and then we'll put 1 counter. So counter we update to 1. So this will count the longest consecutive elements, right? And then next up we have 4 and 1. Okay, next up we take a look at our counter. You can see that, we look up, look down. 3 doesn't exist, 4 doesn't exist, so we just keep our counter as 1. Okay, so then we look at the next number, look at 200. 200 we look up, put it at 1, look up, look down, there's nothing that exists. Okay, so here's where it gets interesting, right? We have 1, and then okay, so 1 we look up, we look down, there's nothing as well. Our counter is also just 1. Okay, so 3 we look up. So we first put in 1.
That's the main issue.
Oh wait, no, we don't even need to put in 1. So we look up, we see a 4. So we add 1 to 1. So we get 2. We'll look down. There is okay, we look down. Then there's no 2. So then we just update this to 2. And I think we would also want to update this to 2 as well, right? Because if you look at 5, Oh, but we won't. I feel like we would want to update everything in between. So, for example, okay, let's try to finish this. Then we have 4, and then we have counter. We update to 2. All right, and then last thing we look at 4, 1. Oh wait, sorry, 2. We look up. There's a 3, so there's 2 for 3. Then we add 3, and then we look down. There's 1, so it's 1 plus 2 plus 1 plus 2 plus 1 is equal to 4. So then our counter is equal to 4. Right, so then do we update this to 4, this to 4, and this to 4? Because if we need to do that, let's say we add 5, right? Because if we add 5 to this, we look up, doesn't exist a 6. We look down, there's a 2, but the 2 is not representative of the longest consecutive subsequence, which is oh, but maybe we only need the top and the bottom of the subsequence to update. We don't care about the middle elements. So we don't care about, so what I mean by that is you have 4, 1, 3, 2. We don't need to update 2. Sorry, we don't need to update 3 or 2. We really need to update the end of the sequence, which is 4 or 1. So that if we add 0 to our sequence, then this will look up and then it'll see that there's 4 here, and then if we insert 5, it'll see that there's 4 here. So I think then, is there a way to store that information? Right. Okay, so maybe there is 1, right? So we take a look up. It's going to be 4. So 4 exists in a hash map and has a value of 1. So we can access 3 plus 1. And then that'll give us to the key of 4. So if we take a look at the key of 4. Then do we also add 1 here too? Oh no. I feel like what we need to do is this. So take a look up, see 4, and then we add 1. So it'll be 3. There exists a 4. We look down. There doesn't exist a 2, right? So then we take 1, which is the value for 3, and then we add 1, which is the value of 4. So we get 2. And then we store the value we store this value. We add 3 plus 1, we get 4. And then we set 4 equal to the value of 3. And we do the exact same for, okay, so in this case, we take 2, for example, right? So 2 has a value of, we look up, it's going to be 2. We look down, it's going to be 1. And then we add 1, so it's going to be 4. But we store the bottom and the top value. We go to the top value, and then we add 2 to 2 to get 4. Set 4 equal to 4. And then set 1 equal to 4. And then that is how we can update our sequence, I think. So that, okay, I think this is what we can do. Okay, so we want to loop through our list. So for I in nums. Okay, so nums, what we want to do is actually first, let's keep a counter. So count equal to 0. And then also we want let's do a dictionary. So map is equal to empty dictionary. All right. So, you know what? Before I do anything, I should probably sign in. And I forgot what my, man. Okay, I might close my stream just for a second. Okay, never mind. My stream's already frozen, so my screen's frozen. I'll just unfreeze it after I check my email on how to reset my password to log into LeetCode. But my internet is super slow for some reason. Yeah, this is rough. Yeah, this is really rough there. So I'm not entirely sure what to do here. Okay, wait. Maybe I could use my... Maybe I could... Oh, wait. Maybe I could use my hotspot, but I think it's starting to load now. Oh, come on, it's so close to loading. It is so close to loading. Okay. Okay, we got it. We signed in. Okay, I just realized Zoom is also on. What the hell? Alright, let me end Zoom real quick. Let me unfreeze my screen as well. Alright, let's see what we're working with here. Nice. So looks good. Alright. Maybe we could look through our list, and then for I and nums. Okay, so we have our key is equal to I, our value is equal to 1, right? We check if key not in map.keys. Right, we only care if our number isn't in the actual hash map itself or the dictionary. Okay, so if the key is not in the map, then what we want to do is we want to check plus 1 in map dot keys, value plus, so high is equal to, I feel like there's got to be like a easier or one line function to kind of get or default. I don't remember it, so I'm just going to use this for now. High is equal to map key plus 1 if key minus 1 in map dot keys. We'll do low is equal to map. Oh, yeah, I think map is going to be, let's do num dict. I think map might actually be a function in Python, so yeah, let's not do that. Key minus 1. Okay, so we have low and high, and so value is equal to high plus equal high, low, plus equal high, equal to value plus high plus low. Alright, and then we could take in our, what's it called? For our numDict, we will add our key, it's equal to value, and we'll also numDict key plus high is equal to value, and numDict key. Oh, right. Okay, so actually, let's do this. Value plus equal high, and then maybe we could do 3 cases. So if key plus 1 in numDict.keys and key numDict.keys. Yeah, let's do that actually. Keys. Okay, so here we go. Fix that. So we have 3 cases, and then value is equal to value. So it's high. Oh, value is equal to high. Right? Yeah, minus low, I think. Should be. Is equal to value. numDict is equal to value. Alright, so I think this should be good. Now, last thing is count is equal to max count value. Alright, and then I think we can return Count. So how do we actually run this? Oh, oh, wait. I feel like this should be right. Oh, shoot. Okay. Yo, what's good, Teddy?
What's good, man?
I'm streaming outside doing some leetcode.
Why are you doing some leetcode?
Because I want to become a...
You're doing business at this point.
I know, but I was doing it
with.
with my friend Rudy. We were trying to practice a little bit, sharpen up.
Alright, have fun. Probably I'll do the wings at what, like, when do you want them? Like, 8-ish? Wow. They might be ready, like, later, like 9, but... Is that okay?
Yeah, that's fine. Wait, what are you doing right now?
I'm going to the gym, and then I gotta actually get the sauces from Trader Joe's, and I gotta get some shit at CVS.
Okay, I'll go with you if you get the sauces. Yeah,
You want to just meet me at the gym then at some point when I'm done?
Wait, which
Because
one?
I'm gonna go to the CVS to get baking sheets and some stuff for Josh, and then I'm gonna go to Trader Joe's and just get some sauce.
Okay. Yeah, wait, can you call me when you're done?
I'll call you when I'm like 10 minutes from done. Actually, wait, are you just gonna be here?
Yeah.
Oh, so then it's like a 5-minute walk for you. Okay, yeah, I'll let you know.
Alright, good luck. Wait, are we still running tonight? Alright, let's do it. Alright, so I saw an error. I think I know what the error is actually. Yeah. I think this is the error. Alright. So let's run this. Shoot. Okay, so we did get this case right, but it's automatic. It's still at 4. Okay. Oh, shoot. Alright. Nice. Okay, let's try to submit this. Let's see if this works. Alright, it's taking a while, which I don't know if it's a good sign or a bad sign. Fuck. Okay, so time limit exceeded. Oh my god. Alright. So probably what's going on here is I think I might be calling the keys function too often. Alright, this might be where I need to figure out how to actually check if something exists. How to check if key exists in dictionary Python. Oh, we don't even need the D or we don't even need to call. Shoot. Seems like okay. Which one is it? We don't even need to call this. We just have to call non-dict. Okay. I think this probably makes this easier, because that way, hopefully, this is going to be big O of just 1. This in itself should just be big O of 1. And then, I think previously, if we call dot keys, that would be big O of N. Alright. Let's try submitting this. Oh, wait, what? Oh, okay. Alright, let's please. Let's go! Alright, we got it. You know, I have to admit, I did not expect us to get this first try. I'm not gonna lie. Okay, this wasn't first try, but it took a few tries. But we got it. Let's fucking go. Alright. I'm excited. I'm excited. So I feel good about this. I'm gonna. Okay, so I think maybe the plan should be if I'm actually going to try and do these problems, it'll be helpful to create some flashcards and maybe not memorize exactly how the code works, but kind of remember how the logic works and be able to hopefully remember things instead of having to go through them every single time. I think that's probably an interesting idea. All right, memory's not too great though. So I'm sure there's probably going to be lots of ways to do this. I so I think for this, memory is going to be big O of n. So it's time complexity. It's big O of n. I'll call it time complexity. Big O of n, and then maybe space complexity is also big O of n. Since that we have to actually instantiate a dictionary to hold everything, and then actually putting in this dictionary is going to take big O of n number of spaces because we're scaling our dictionary as we look at more elements in a list. Okay, so I feel like this is pretty good as a starting point, right? Maybe this is where I can kind of take a look at how do we write this in a more clean way. Because right now, right, there's kind of three competing there are three competing if statements that I feel like can get truncated down. But let me write down my logic before I forget. Alright, so let's create a deck and we'll call these leetcode questions. Alright. And then I'm going to create within this arrays and hashing. Okay, I'm also getting a call from Rudy, so I'm going to pick this up real quick. Hey, Rudy. Yeah, I just found out what it is, or just figured it out like 2 minutes ago. Did you finish it too? If not, then I can wait a little bit. Oh, yeah, hash map. I think the hash map's probably the easiest way to do this. Wait, is it okay if I put you on speaker? And I'm also streaming, by the way. Is that okay? I'm putting this on YouTube. Okay. I'm gonna... Alright, yeah. What were you gonna say?
My idea is to basically just go through the list and make a hash map.
Yeah.
And basically, if we encounter an element that we haven't seen before, we add that to the hash map. And so we add it to the hash map, and then we basically do two things.
Yeah.
We see if the previous element exists and if the next element exists.
Yeah.
And then basically the hash map is just supposed to hold key and value pairs. So I'm thinking like the key is going to be the number that we're on, and then the value is basically going to be nil. And that nil should be updated to the next value if it exists.
Okay. I think that's kind of where I started too. That's kind of the starting point. And then there might be a trick that will cause your, I guess you could say, algorithm to maybe fail at some point. You could try it, see if it works.
Okay. Yeah, so I'm gonna go over it. I think I need maybe about 8 more minutes is what I'm gonna give this.
Okay, but give it a shot, and then I feel like that's exactly what the logic I had.
All right, I'm gonna give this about 8 more minutes.
Okay, sounds good.
All right, I'll call you back in 8 minutes.
Okay, yeah, I'll see you ready. Peace. Okay, so oh shit. Okay, so I'll just leave it as this, honestly. Alright. I think alright, so leetcode / algorithm question. Okay. So I think first thing maybe we want to do is identify what maybe data structure is helpful for us to use in this problem. And I think in this case, hash map is probably the way to go. It's even in the hash map section of our, what's it called? Of the leetcode thing. So this is going to be interesting, I feel like. This problem is one approach is to use a hash map. So give a high level approach to how this problem can be solved. Okay, so one approach is to use a hash map, right? So the hash map is to use a dictionary. Call this hash map. Okay, the hash map so high level idea. So the hash map will store key and value pairs. The key being the actual. So let's try this. Keeping the actual number in the list, and then value being the. Okay, so the value is gonna equal the actual number in our list, or sorry, keys, and then value is going to equal the, oh shoot, so value, how should I say what value is? It's not going to be the actual number on the list, but maybe the count of consecutive. Okay, the count of the consecutive elements, right? Alright. So if we want to take the value then, okay, so value, this is going to be the actual, not the actual number, but the length of the consecutive sequence for the corresponding number. Okay. High level idea, a hash map will store a key and a value pair, and the key is going to represent the actual number in a list, and then the value is going to be the length of the consecutive sequence for the corresponding key. Did I spell this right? Consecutive. Alright, there we go. Okay, so the length of the consecutive sequence for the corresponding key. Alright, that's good. Okay, so we have a hash map, stores the number and then also the length of the consecutive sequence. Now, in order to write an algorithm in big O of n time, our algorithm needs to scale linearly with the input. So this means setting up a single pass or less. We're probably going to need a single pass through the list of numbers, right? The algorithm needs to scale linearly with the inputs, so this means setting up a single pass through the list of numbers, right? Okay, so each iteration care about one thing. Each iteration take a look if the number exists in the hash map. Okay, let's do a dictionary. Let's keep it consistent. So in the dictionary, if it does, then we don't care about it. If it doesn't, then we need to add it to the dictionary. The goal of this hash map, fuck. I keep realizing that. So the goal of this dictionary is to help store the lengths of different sequences that we've seen. Okay, so that's the goal, right? This dictionary is really to just store the different lengths of sequences that we've seen. And then, big idea of big O of n, the algorithm needs to scale linearly with the input. Alright. Hey, Rudy.
Can you hear me?
Yeah, I'm here.
Yeah, what's up? I fixed the bug that I had.
Nice.
But yeah, I'm pretty much stuck with the issue of like once I get the hash table with all of the links,
Yeah.
then how am I gonna follow that link to make the biggest counter?
Yeah, that's probably the hardest part. That's definitely the hardest part in my opinion. So what are you putting as the value? What's the link thing you're talking about?
Let me take, so basically, take for example the input where they give us of 037258461, right?
Okay, example 2.
Yeah.
Yeah.
So, in the hash map, I have 0 goes to 1, 3 goes to 4, 7 goes to 8, 2 goes to 3, 5 goes to 6, 8 goes to 0, 4 goes to 5, 6 goes to 7, and 1 goes to 2.
Okay, I'm gonna need to build this out because I can't keep everything in my head like that. So I have to.
Screen. Well, I can take a picture first here. I guess let me quick picture. Let me see.
You said you're gonna send me a screenshot.
A picture, yeah.
Okay. So you said 0 goes to 1.
Okay, can you see it?
Yeah, let me check. Okay, wait. Okay, so 0 goes to 1, 3 goes to 4. Alright, 7 goes to 8. 2 goes to 3. So, I'm curious, how did you create these? How did you create this?
I just looped through the array once.
Right.
And I created a hash map, so if it doesn't have the key, then basically we'll add it.
Okay.
So we'll say hash map key is equal to nil. And
Right.
I have 2 extra if statements. So if the hash map has the previous key value, then we'll update the current one. Well, we'll update the previous one, the value of the previous one. Instead of it being nil, we'll set it to what the current value is. And then if the hash map also has the next key, then we'll update the current one's nil value to be the next value.
Okay.
So those are the only 2 if statements I have there. So now I have the little connections here, but now I have to actually figure out how I would follow the connection.
Oof. Right.
To basically count it up and find the biggest number. I was thinking about maybe making a linked list, but because it has to be in time O of n, I don't think making a linked list here would work.
Yeah. The solution that I was able to use, it's pretty simple. I was able to get it done in a single pass. Like a single iteration. So there seems to be a simpler solution to the linkless idea.
Okay.
I'm trying to think of how this would work if you were to use this strategy of linking things.
How does your solution work?
You want to hear it?
Yeah.
Okay. So basically, instead of the links that you've added, 0 goes to 1, 3 to 4, what I did was I linked, okay, link is a bad word. I set the key to be the number in the list, and then the value to be the length of the subsequence or the consecutive sequence that includes that number. So I think for the first example, that's the one that I used. I'll try to send a
Okay,
picture
because
here.
I think I understand what you're saying. So instead of keeping track of the links, you'll just basically say, if we have for example, 0 goes to 1. So we have 0, 3, 7, 2, 5, 0. It doesn't have -1 and it doesn't have 1, so that should be 0, 0.
I think
3.
it should be 1 because a single element or a single number, the length of that sequence is a single number. So I always set it to 1 by default.
Okay, so 1. So then 3, it doesn't have the previous or next, so that's just going to be 1. 7, it
I was just working on some leetcode with
Actually, is this a leetcode grinder?
so it's still going to be 1.
Yeah, just my friend Rudy.
Okay, my bad for interrupting.
That's
my
okay.
bad.
Sorry.
Alright, well, I'll let you get to it, dude.
Yeah, it's you, Alex.
You look like a certified grinder right now, bro.
I'm maximizing shareholder value. That's what I'm doing.
Alright, we should hang out soon.
Yeah, down to go to the dining hall whenever.
Alright, sounds good. See you,
Yeah,
bro.
see ya. Sorry, Rudy. I just saw my friend Alex real quick, but sorry, what were you saying?
So like 0372, when we get to 2, I'm assuming that's where you would increase the value. Instead, you'll get the previous value of 3, and you'll probably increase it, so 2 will be 2.
Yeah.
Is that right?
2 will be 2, and then there's a problem where, okay, let's say the next value you insert is 4, right?
Right.
And then you look at 4, you look at the top value, or you look up 1, you see there's no 5 in our list, but if you look down, there's a 3. But the value of 3 is still 1 because we didn't update that when we put in 2 into the hash map. Does that seem to make sense a little bit?
Yeah.
Okay, so that's one of the problems I had, and there's a kind of a trick you can do to make sure you're updating the numbers you need to update so that the next iteration you can see the actual consecutive sequence from the top and the bottom value.
Can't you just update it when you get, like when you get 2, you can't just update 3 to be 3-2?
Yeah, you're going to need to update that to be 3-2. And then the problem I had was, let's say you have 2-2. So you have 2 at the bottom, and then in your hash map, you have 3, 4, 5, 6, 7, 8, 9, 10. And so do you have to update all of those 9 numbers? Or can you just update maybe a single number or 2 numbers, and that'll change and make sure that your algorithm works correctly?
I see. So were you able to get your thing to work on all of the test cases that they gave?
Yeah, pretty much.
Oh, interesting.
But try that out. See if it goes anywhere. And if you have any problems, we could try to talk through it. See if what I'm thinking makes sense, or if it actually works.
I'm just gonna jot that down.
Okay. Oh shit. I just saw on the news that Iran launched some drone attacks on Israel. Fuck.
When?
An hour ago.
Okay.
Damn. Alright. Hope. Shit.
Just give me 1 moment here.
Yeah.
Alright, so yeah, I wrote that down. I'll implement it later.
Okay.
Yeah, that's pretty much it. It was nice doing some LeetCode here, I guess, for a bit.
Yeah.
So,
You want to meet again this week or upcoming week?
yeah, sure. What day were you thinking?
So, I'm down Thursday, and then also Saturday or Sunday. If we can meet twice this week, if you're free.
Yeah, Thursday and Saturday is good with me because, I mean, now that the internship is over,
Yeah.
I got definitely more time.
All right. How did the final presentation go? Pretty pretty good.
There was no real final presentation. We had a final meeting on Wednesday.
Yeah.
It kind of pissed me off a little bit that I didn't really get as much work done because I was too busy helping one of the other interns who kept asking me like, "Oh, dude, I'm stuck here. I got a million questions, blah blah blah, all this and that."
Right.
So I was like helping him out, and then it's like Wednesday I didn't really have much ready,
Uh huh.
and like the other dude who I was helping out, like he had way more done than me, and I was like, "What the fuck, man?" It wasn't really something big. Like they just wanted us to make a small program. I made a small program.
Yeah.
Like I told you, all it's supposed to do is two things: either convert a file or verify a file.
Right. Right.
So with the convert file thing, I basically
Okay.
had something similar to that, but it only was an Excel file, so I was
Yeah, I'll call you Thursday, maybe after 5. Okay, so I'm back. I'm gonna try to really quickly sum this up and then probably end the stream here. Let's see. Yeah, it's been almost an hour. Okay, so each iteration takes a look if the number exists in the dictionary. If it does, we don't care about it. If it doesn't, then we need to add it to the dictionary. Adding it to the dictionary, we'll need, when adding it to the dictionary, we need to check if there are elements that are above and below, meaning +1 or -1. The number to the dictionary, check if there are elements that are above or below. Okay. Ideally, the values of the elements above and below will have the length of the consecutive sequence that starts or ends with that number. Okay, so, oh right, that starts or ends. So this is gonna be starts is above or ends below that number. That number, okay. Right, okay, and then ideally if there are elements that are above and below, meaning +1. Okay. Whenever we update, right, maybe the final step is to update, then those values exist, we add them to the length of the current number. The final step is to update the beginning and end of the sequence. We don't need to care about the values in between, but only the end and start where new values get added. Okay. To do this, we can save the length of the above and below values, then access the dictionary by the start and end of the sequence by adding the above value and subtracting the below value. Alright, yeah, so this is kind of a pretty long worded answer, but I think this kind of grabs the gist of what this algorithm does. I think it's time, big O of n, space is also big O of n. Above and below. Those values exist, we add them to the length of the current number. To update the beginning and end of the sequence, we don't need to care about the values in between, only the start and the end where new values get added. Alright. There we go. Access the dictionary by the start and end of the sequence and adding the above value and subtracting the below value. Alright. Nice, so that's good. Alright, I think with that, I'm happy to end here. Probably gonna go back to my apartment. It's a bit chilly outside, so go back to my apartment and then finish one of the books I'm reading. I don't know if I'll finish it, but try to get some progress done. So thanks for tuning into the stream, and hopefully this will be one of the streams I keep doing. So catch you guys in the next one. Peace.